Today we're continuing on with quadratic formula and doing this second lesson over this topic. Remember that the quadratic formula is the fifth and final method for solving a quadratic, something with an x squared for x, and it's the only method that works on any quadratic. It works every time. So let's remind ourselves this is what it looks like. You do not have to memorize this. I think you'll find that you'll accidentally memorize it. But the biggest thing is you have to know how to use it to solve for x. Now, there's really only one difference between what we did yesterday and what we're doing today. And that difference is just how we're going to write our answers. Okay, yesterday, if it wasn't a whole number, my answer for x, then you were asked to round to the nearest tenth, round to the nearest hundredth. We rounded off those decimal answers. Today, we're not going to do that. We're going to give the exact solutions. So no rounding today. I'm not going to approximate. So that's exactly what I want to put there. What this means is that we're going to write our answers in simplest radical form. Yay, factor trees. Okay, so instead of putting the square root of 62 in our calculator, I'm going to do a factor tree on that and replace that simplified answer instead of a decimal answer. Okay, so let's kind of show you what that's going to look like. Now, the directions say find the roots. Okay, I point this out a lot. I'm going to do it again just so that way you're not confused come exam time. The roots, that's just another name for the solutions. Comes from the square root method. Remember, they could also say the x-intercepts. That comes from graphing. And they could also say find the zeros. And that kind of stems from all the methods. It's like, what can I plug in for x that actually makes this equal 0? So we call them the zeros. Okay, all those things mean just solve it. And they should definitely take note that they want me to write my answer in simplest radical form. So make sure you read the directions closely, because sometimes they'll say simplest radical, sometimes they'll say rounded. Okay, so it does make a difference. Example 1. Okay, it's in standard form, x squared x, then the c value, and it equals 0. So I'm good to say what a, b, and c equal. A is 7, b is negative 10, c is 1. Okay, so I'm going to go ahead and plug it into the quadratic formula. So it would be the opposite of b. b is negative 10, so I'm going to do positive 10, plus or minus the square root of negative 10 squared. Remember, the parentheses make a huge difference. Minus 4 times my a value is 7, and my c value is 1. All of that needs to be divided by 2 times a. A is 7. Okay, remember last time we figured out what sat under the radical, and at the same time we could go ahead and simplify the denominator. So I got 10 plus or minus. I'm going to plug what's underneath the radical into my calculator all at the same time, parentheses and all. And I get 72. On the bottom, 2 times 7, that's just 14. Okay, yesterday we went ahead and said, okay, 10 plus square root 72 divided by 14, and I typed it into my calculator, and then I divided by 14, and I would have said 1.3. That is the answer, but they're not asking me to write it that way. Okay, simplest radical means from this step, I need to take square root 72, and I need to factor tree that. Okay, that's what they want me to do. So let's see, maybe you don't know what goes into 72, so you just divide it by 2. Okay, 36, I could do 6 and 6, and then 3 and 2. So I'm going to rewrite this. Let's see, I see a pair of 3s, a pair of 2s. So 3 and 2 would come out, making 6 on the outside. And that 2 would stay underneath. So 6 radical 2. I'm going to replace square root 72 with 6 radical 2. Put that after the plus or minus. Honestly, I think simplest radical is maybe a little bit easier because I don't have to plug the final answer into my calculator. I can kind of just leave it like this, but there is one thing that I'm going to do to make this better. So let's jump down to the bottom here. Think about how many solutions this problem has. Well, it has 2 because I can do 10 plus 6 square root 2 divided by 14, and then I can do 10 minus 6 square root 2 divided by 14. Okay, so there's 2 solutions. You can make this look better. Okay, I'm not going to put in my calculator, so I'm going to leave it as this weird looking fraction thing with the plus minus sign. But you can reduce this fraction. To do that, you need to be able to divide a number out of all 3 numbers. And what I mean by the 3 numbers, because it kind of looks like there's more than that, I mean all of the numbers that are on the outside of the radical. So check it out. This is the answer, but I can make it one step better. Basically, I'm ignoring the radical 2. If all the other numbers can be reduced or divided by some number, then you want to go ahead and do that. So I noticed that all of those numbers are even, so I'm going to divide all of them by 2. 10 divided by 2 would be 5, 6 divided by 2 would be 3, 14 divided by 2 would be 7. Okay, I want to change all of those numbers and then write my final answer. So the best answer is x equals 5 plus or minus 3 square root 2 over 7. That's a 3, got a little sloppy. And again, if it says simplest radical, I'm not going to go to my calculator. I can kind of just leave it, which is kind of nice in my opinion. All right, I want you to try number 2 on your own. Let me make a note that say that those 3 numbers weren't all even, or there wasn't a number that went into all of them, then you would just leave your answer like that. Okay, you wouldn't have to reduce. You can't always reduce, that's okay. All right, I'm going to do one more. You're going to try 2, and then we're going to call it a day. If I look at number 3, I notice this is not in standard form because it has to equal 0. So you have to move that over. If you use a positive 3 as your C value, you're going to get the entire thing wrong. So be careful. Make sure it equals 0. Okay, honestly, this is the same process as what I just did, but practice makes perfect. So the opposite of b would be negative 6 plus or minus the square root of b squared minus 4 times 2 times negative 3. All of that over 2 times 2. Okay, I know that I need to figure out what sits under the radical and what's on bottom. So it's 60. 2 times 2, there's 4 on bottom. Okay, it's going to say simplest radical. It should say it there. Yeah, the directions are still the same as up at the top. So I'm going to take square root 60, and over here, I'm going to factor tree it. So let's see, 6 and 10, 3 and 2, 5 and 2. So I see a pair of 2's. 2 comes out, 3 and 5 stays under, so that would be 2 radical 15. Instead of writing square root 60, I'm going to put 2 radical 15. Here's an example. I will tell you right now, the number 2, the one you do, you can't reduce it at the end. You just leave it. This one can be reduced, so I want you guys to finish that. Okay, show me how you would reduce that. Write your answer here, and I'm going to check that tomorrow.